Wait, let me just finish my fucking food, bro. I swear to fucking God. So fucking hungry. I'm having lemon rice right now. Hmm. Hmm. I feel like I'm in heaven right now. I swear to fucking God. Guys, I'm one follower away from 200 followers. If you're new here, please be sure to subscribe or follow me. I'm so fucking honored to have you guys here watching me right now. I swear to God. Love y'all. Thank you so much for having me. And thank you so much, God, for letting me have this fucking delicious lemon rice. Hmm. Alright, y'all can talk to me in chat. I'm here. Say hi. Okay, that's how it works. I'm not asking for any donation, any subs. Just please be in the chat and talk to us so I can talk to you and we can all talk to each other together. How about that? Alright, I finished up with group velocity and phase velocity right now. Let me let me introduce you all to what I've learned right now. Okay, so I'm doing black body radiation at this point. Okay, so I've just done wave particle dualism. So what it means is like when the wave particle acts like a particle, it occupies space, certain velocity, certain mass, and also certain position. The moving particle possesses some certain amount of momentum as well. The energy defined defined for the particle is given by the kinetic energy, potential energy, as well as the rest mass. All right, this is what you get. Now we move on to de Broglie matter waves. Microparticles associated with waves like properties to MV. Okay, so we write EV, which is energy. Okay, we write it as half P squared by M, and therefore we get the P is equal to root of 2 EV into mass. Now, here's what, okay? We also know that de Broglie wavelength is also a thing. Alright? Wait, what the fuck just happened? Okay, here's what you do. Okay, EV is equal to half P squared by M. So what do we do after that? We interchange the LHS and RHS. We take P to the LHS and we take RHS back to EV. So what it gives us is P is equal to root of 2 EV into rest mass. Okay, that's M that we give. Now de Broglie wavelength us by lambda is equal to value of an electron. You know that, right? 1.6 into 10 is to the minus 13 minus 19. Okay, and the mass is 9.1 into 10 is to raised to the power minus 31. So what it gives us is that 1 to 0.27 Armstrong divided by root V is equal to the de Broglie wavelength. Now listen, I know it's all sounds very complicated and everything, but I need you. Right, there's anyway on a 10-second delay. Now that I've realized, we should still get it on. Alright, here's the thing, okay? The de Broglie wavelength that is given to us is lambda by h by p. We can write p as mv. Okay? So, right, as you can write p is equal to as m into v. So we get half p squared by m squared. EV is equal to half p squared by m squared can be written as p is equal to root 2 of EV into the rest mass given to us. Okay. Now the de Broglie wavelength is given really bad teacher, and especially because I'm really drunk right now, I cannot explain shit, but I'm over explaining as much as I can. I hope you guys can get what I'm trying to say. So, oh, why did the stream just go off? Every time the stream goes off, I shall go eat a bite of the lemon rice. EV is given to us. Okay, we calculate all that shit. H is equal to 6.625 into 10 is to my minus 34. E is equal to 1.6 and also the rest mass. All right. So here's what we go through when we're going through the de Broglie wavelength. Okay. The size of the particle is proportional to the wavelength, and the velocity is inversely proportional to the wavelength. Whatever you understand, size of the particle is proportional to the wavelength, and also the velocity is inversely proportional to the wavelength. So what do we understand through that? As the size of the particle is larger and also increase, and if the velocity particle larger, the wavelength of the particle is along with it. Okay, wait, I think it died again. I don't know why it's dying, bro. Can you all see? Hey. It's very funny that a motherfucker who does not like physics and maths is really teaching somebody online how to learn physics and maths. Trust me, it's very fucking annoying for me. I hate physics and I hate maths at the bottom of my heart. I swear to God, I don't like either of these subjects. But listen, I'm gonna do it because I can do it. And if I can do it, even without not liking it or being good at it, trust me, motherfucker, you can do much better than I can. So I'm just watching myself with like teaching you, and I know how embarrassing it is, but I must still continue no matter what. Let's see the phase velocity. We denote it as V and subscript P. Okay, it is a transport of imaginary point on the wave with respect to wave motion. Now we don't know we denote Vp is equal to omega by k. Omega is the angular velocity and k is the propagation constant, also known as the wave vector. Now you can write omega as 2 pi nu. Do I say do instead of differentiation? Is that it's partial differentiation. That's why we say do. Okay. Now you take do. You take a differentiation with respect to k. Okay. And you take only the terms of omega. Quanta actually is. Give me 1 second so I can give you like the proper definition of quanta. Just 1 second. So quantum theory is physical significance tells us that radiation is made, and I hope that it is like sufficient. I guess I don't know. Okay, so we go on with Heisenberg uncertainty principle. So the Heisenberg uncertainty principle tells me, and simultaneously. This is what I told you a few seconds ago. The product of uncertainty is of individual parameters will be greater than or equal to h by 45. And simultaneous value physical variables that describe atomat- uh, atomic system. We already know that we cannot find the precise values of the atomic system. Okay, this is what Heisenberg's uncertainty principle tells us. All right, so uncertainty quantum mechanics. So this is all that was in the module of mine. Now we actually learn through the notes that I wrote during the class. Heisenberg uncertainty principle. Heisenberg uncertainty or noodles I'm left with. H by 45. Now listen, as much as you don't have any idea why me too, dog. Okay. me fucking do. Now, here's what I think. Here's what I fucking think. Okay. Right. Recording is time independent and time dependent equation. We shall cover. We shall cover this all today. But before all that happens, I'm gonna go smoke and your shit. Now, tomorrow, as you know, it's Halloween, and I'm gonna be dressing up as Kaizako Oni Orevanaru. Okay, a literal translation, but here's what I'm here to tell you guys. I'm gonna be the king of the pirates for tomorrow, 31st October. So if there's anybody in Church Street who's trying to steal my idea, listen up. I'm gonna fuck you up, buddy. I'm kidding. I hope there's somebody else dressed as Luffy and I'm not the only one as the wannabe motherfucker over there. Tomorrow we're gonna have shitloads of fun, bro. Shit fucking loads. Trust me. We will. Alright. We gotta finish. We gotta finish a few things. Okay? Oh yeah. After group velocity, quantum mechanics, Heisenberg uncertainty principle, this is where we get to. When wave packet is for wave when wave packet is small, you can get the accurate positions. Okay, that too precisely. But when the large wave packets exist, position cannot be determined accurately, but momentum can. So here's what Heisenberg's uncertainty principle tells us is that it is impossible to determine the values of position and the momentum accurately and simultaneously. We can't determine values of position and momentum accurately and simultaneously. The product of uncertainties of individual parameters would be greater than or equal to, wait, here's, okay, by pi by 4, h by 4 pi. So here's the last point of Heisenberg's uncertainty principle, which tells us that the product of uncertainty of individual parameters will be greater than or equal to h by 4 pi. Now, why is it h by 4 pi? Don't fucking ask me. Do I look like a fucking physics teacher to you? No. Simply, I don't even know why. It is what it is. Let's go on with it. Now, in any simultaneous determination of position and momentum of a particle, the product of corresponding uncertainties inherently present in the measurements is equal to or greater than h by 4 pi. This is what we learned. Okay, so we get a expression that is delta p dot delta x greater than equal to h by 4 pi. All right, in any other certain uncertainty relations, in any other uncertainty, wait, relations, we get delta p dot delta x greater than equal to h by 4 pi. This is uncertainty in momentum. Okay, these are all just the theory part. We also gotta do questions right after we are finished with all of this shit. Now, we get the uncertainty of energy, that is delta E dot delta T greater than equal to h by 4 pi, which is uncertainty in energy. And now we get angular displacement uncertainty, which tells us is that delta L dot delta theta is greater than equal to h by 4 pi, which is the angular displacement uncertainty. Not a forget. Now, we don't have anything else. Now, in all of these expressions, the delta L is the uncertainty in angular momentum. The delta T is uncertainty in time, and the delta X, is the uncertainty in measurement of position. Okay. Now, here's what you gotta note. Okay, that non-existence of electron inside a nucleus. Frequency of radiation emitted by an atom can be determined. Binding energy of an electron in an atom. Polar electronic orbital of an electron. Dual nature radiation. Definition of okay, I don't even know. These are the physical significance of Heisenberg uncertainty relations. Non-existence of electrons inside the nucleus atom, calculation of frequency of radiation emitted by an atom, calculation of binding energy of an electron in an atom, determination of radius of Bohr electron orbit. The wave and particle properties are complementary to one another. It is impossible to determine precisely and simultaneously values of physical variables which describe the atomic system. So here's where we write. There's also a note here. Heisenberg's uncertainty principle could also be expressed in terms of uncertainty involved in the measurements of physical variable pair like angular displacement theta, angular momentum L. If we try to measure the position of particle accurately, then there is an uncertainty in the measurement of its of this momentum and vice versa. Thus, it's impossible to determine precisely and simultaneously values of physical variables which describe atomic system. Uncertainties from some such experiments can be greater than given by these relations, but never smaller. Uncertainty is valid even if we use sophisticated instruments and techniques. Uncertainty relation is an inherent property of nature or matter. Wave properties and particle properties are complementary to one another. Physical significance of Heisenberg uncertainty principle, okay, which is non-existence of electrons inside nucleus. Non-existence of electron inside nucleus, calculation of frequency of radiation emitted by an atom, binding energy, calculation of binding energy of an electron in an atom, determination of radius of electron, Bohr electronic orbit, to determine the wave and particle properties, wave and particle properties are complement to one another. Now, complement means the exact opposite, right? That's what it is. Like if it's 0, then it will be 1. If it's 1, then it will be 0. If it's 0, 1, it will be 1, 0. If it will be 1, 0, it will be 0, 1. Okay. It is impossible to determine precisely and simultaneous values. Impossible to determine possible and To determine precise and simultaneously values of physical variables. Alright, I need a little break. Alright, we're gonna revise whatever the fuck we've studied till now because it did not go into my head. So we're starting with wave particle dualism. Particle occupies space, certain position, and also mass. The moving particle does not have anything but possesses momentum. Energy of the particle is given to us by kinetic energy, potential energy, and the rest mass. All right. For the wave is just a propagation of disturbance. Energy depends upon the amplitude and the frequency, wavelength, and also the phase. The de Broglie matter waves tells us that microparticles are associated with wave particles and are henceforth called matter waves. Kinetic energy for a particle is given to us by E is equal to half mv squared. Now we multiply the equation by mass and also divide it by mass. So we get the equation as E is equal to half m square v square by m. Now we know that P is equal to mv. Okay, so we write m square v square as p square. So we get EV, that is energy, is equal to 1 by 2 p square by m. So what do we get? P as root of 2 MeV. De Broglie wavelength to us can be given as h by p, which is h by root 2 MeV. So when we finally calculate it as, it gives us 12.27 Armstrong by root V. The value of H is 6.625 into 10 raised to minus 34. The value of E, we know the electron is 1.6 into 10 raised to minus 19. And the mass is given to us as 9 into 10 raised to the power minus 9.1 into 10 raised to the power minus 31. The size of the particle is directly proportional to the wavelength, but the velocity is inversely proportional to the wavelength. If the wavelength is more, the velocity is going to be lesser. If the size of the particle is larger, the wavelength is going to be larger too. The phase velocity is just the transport of imaginary point on a wave with respect to wave motion. So we write Vp is equal to omega by k. Now, omega can be written as nu 2 pi nu, and k is equal to 2 pi by lambda. So we can write wave velocity as equal to nu into lambda. Okay. Now group velocity, which is represented as Vg, is given to us by dou w by dou lambda, dou k. Okay. Now what does dou mean? Dou is basically the partial differentiation. Okay. Now it is given as Vg is equal to dou omega by dou k, which is with differentiation with respect partial differentiation with respect to k of omega. Okay. Now we move on to quantum mechanics, that is Heisenberg uncertainty principle, which tells us the dual nature of radiation. Particle is associated with wave within wave particles. When wave packet is small, you get accurate positions. But for larger wavelengths, position cannot be determined, but the momentum can be. Okay. We cannot determine the value of position and the momentum accurately and along with that simultaneously. That's obviously positive, like really obvious too, right? Because once you're determining the value of the position and also the momentum of a particle, by the time we calculate that, the whole position and also the momentum will also be variable, right? So it will change by the time you will be calculating it. Okay. So for larger wavelengths, position can be determined, but position cannot be determined, but momentum can be. Okay. The product of uncertainty of individual parameters will be greater than or equal to h by 4 pi. The value of h is given to us by 6.625 into 10 raised to the power minus 25. We've already done that before. Now, here's what we have a equation delta p into delta x is greater than or equal to h by 4 pi. Okay, in any other certainty relation, delta p dot delta x greater than h pi is the uncertainty in momentum. Delta E dot delta T greater than equal to h by 4 pi is uncertainty in energy. Delta L dot delta theta greater than equal to h by 4 pi is uncertainty in angular momentum. We already know what omega is, we already know what L is, angular momentum, and we already know what omega is, and already know what delta theta is equal to. Now, we learned the physical significance of de Broglie, non-existence of electron inside nucleus, calculation of frequency emitted by atom, calculation of binding energy in an atom, determination of Bohr electron orbit, wavelength and particle properties are complement to one another. It is impossible to determine precise and simultaneous values of physical variables. Alright, here's where we stopped before the break. Okay, now we gotta get back to the beta decay experiment. There's so much to do. So, okay, we're gonna get the speed of. Wait, let me study a bit and then I'm gonna recite it out for you guys. Alright, I gotta watch a video for sure. Right, we get started with. Alright, honestly, I'm done with all this shit right now. I'm just gonna practice for tomorrow on how to carry the camera for Halloween. So I'm gonna be carrying it like this, and I hope that it is okay and that I can walk around like this. So yeah, welcome to the tour of my room. This is Moy. My mother made this for me, and well, there's nothing much to see. I shall be ending the stream real quick today, as you know that I'm pretty slaushed, and well, I can't do this shit right now. So I'll see you guys in the next stream of mine. Well, let me show you guys what I'm gonna be wearing for tomorrow, though. That is for sure. Tomorrow is Halloween in India, so we're gonna be dressed up as Monkey D. Luffy. Oreva Monkey D. Luffy. Kaizuko ni